Friends, welcome to BrainFlex tutorials. In this one, we are going to talk about significant figures. So we will begin by talking about the first 6 laws that you need to know under significant figures. Then from there, I'm going to show you 2 laws that you need to know beside the 6 laws. These 2 laws has to do with how to work out multiplication and division. The other law has to do with how to work out addition and subtraction. Then at the end of the video, we are going to answer some exam questions. Okay, having said that, let's begin. So we have our first law, which is non-zero digits are significant. So what this means is that if you have a number like 3.23, we can say this one has 3 significant figures. This one has 3 significant figures. Reason why is because we have 3 non-zero digits. So non-zero digits, don't forget they're what? They are significant. Okay, let's take another example. Let's say we have 1, 1, 2, 3. How many significant figures are present in this particular number? So in this one, you need to see whether your numbers are non-zero numbers. So since every number in this one is a non-zero number, we can say that we have 4 sig figures. So the first rule, it's very simple and straightforward. Let's jump to the second rule. The second rule states zeros between non-zero digits are significant. Let's take this example. 2007. This one has 4 significant figures. Reason why is because this number at the beginning is a non-zero number, and the number at the end is a non-zero number. Therefore, the zeros in between these 2 non-zero numbers should be counted as what? As significant. Okay, what about if we add a number of this kind? 2.008. How many significant figures are present in this particular number? Okay, the rule still applies. The zeros are between non-zero numbers. So we can say it's 4 significant figures. Okay, let's now handle the last rule number 3. So rule number 3 says leading. We are saying leading zeros are not significant. Okay, on this one, pay close attention. It says leading zeros are not significant. So let's take, for instance, we have this particular number 0.00279. How many significant figures are present in this particular number? Okay, the rule still applies. We say leading zeros are zeros at the are zeros before the non-zero digits. So these ones are what we are calling leading zeros. So these ones, they are not significant. So we have 3 significant figures in this case. Very simple, right? Okay, let's make it a little bit hard. Let's say we have 0.00921. How many significant figures are present in this number? I want you to pause the video and give it a guess. Okay, remember the zeros are what? Are leading zeros, so they shouldn't be considered. So we have how many? We have 3 significant figures. 1, 2, 3. So we are saying 3 significant figures. Okay, let's do another example. Let's say this time we have this number. We have 0.09002. How many significant figures are present in this number? Remember, leading zeros are not significant. And don't forget from our rule number 2, zeros in between non-zero numbers, these ones, they are what? They are significant. So in this one, we have 4 significant figures. To find the answer, I need to combine rule number 2 and rule number 3. Rule number 2 states zeros in between non-zero numbers are what? Are significant. But reading zeros, they are not significant. So even if there is a decimal place or there is not, it does not affect this rule. The rule still applies. Okay guys, now let's look at the last 3 rules that you need to know. Okay, so now let's look at rule number 4. Rule number 4 states threading zeros in a number with a decimal point are significant. So let's take, for instance, we have 93.00. This number has 4 significant figures. Reason why? The zeros at the end this side, they are what we call trailing zeros. And since there is a point, we can say they are what? They are significant, because this rule states trailing zeros in a number with a decimal point are significant. So there is a decimal point. So these trailing zeros, they must be counted as significant. So we have 4 significant figures. What about if you have a number of this kind? Let's say we have a number, let's say 8800 point. Yeah. How many significant figures are present in this particular number? Remember, there is a what? A decimal point. So trailing zeros are what? Are significant. So when you say trailing zeros, we mean zeros at the end. So trailing zeros are significant. And remember, from rule number 1, non-zero numbers, non-zero digits are what? Are significant. So we have 4 significant figures. 4 significant figures. Okay, let's look at one more example. Let's say we have 9032 0.0. How many significant figures are present in this number? You can pause the video and give it a guess. Okay, this number has 1, 2, 3, 4. 4, then plus the trailing zeros must be included as well. So 4, 5, 6. So this one has 6 significant figures. So that's how easy it is to state the significant figures of a particular number. Okay, let's now talk about the rule number 5. So let's talk about rule number 5. So for rule number 5, we are saying we are saying scientific notation. In scientific notation, only the significant figures in the coefficient are counted. So only the significant figures in the coefficient are counted as significant figures. Now, what's a coefficient in scientific notation? Okay, so here is an example of a scientific notation. Actually, this is the general format. So you might have this one. By the way, there it's capital letter N. Let's put capital letter N. This part is what we call the coefficient. So you only consider this number when counting the number of significant figures. So let's take, for instance, we have 3.02 times 10 to the power negative 4. How many significant figures are present in this number? So you just need to consider the coefficient. Forget about the exponent. So on our coefficient, we have 3 significant figures. Remember, 0 in between the 90 digits are what? Are significant. So in this one, we have 3 significant figures. What about if you have a number of this kind, negative 92.00? times 10 to the power 3. How many significant figures are present in this particular number? Remember, trailing zeros are what? Are significant. And in scientific notation, or in other words, in standard notation, we only reconsider the coefficient. So on our coefficient, we have 1, 2, 3, 4. So we say 4 significant figures. We say 4 significant figures. Okay, guys, that's it for this rule. Let's jump to our last rule, which is rule number 6. Please, on rule number 6, pay close attention because it's a little bit hard to understand. Okay, rule number 6 states exact numbers, count of objects, conventional factors. These ones have infinity significant figures. It has infinity significant figures. In other words, it has unlimited number of significant figures. Okay, let's begin by our first one, exact numbers. Let's take, for example, a good example of exact numbers can be the root of 4. We know that the root of 4 will give us exactly 2. So if you're given to evaluate this particular question and state the number of significant figures of your answer, we can say this one has infinity sig figures. It has infinity significant figures. Reason why, it gives us what? Exactly value. Okay, let's take another example. Let's say the root of 9. We know that the root of 9 is 3. So this one is also, we can say this one also has infinity significant figures. Okay, I guess you understand what I mean by exact value. So if you evaluate something, and after doing your evaluation, you are getting the exact value, then the number of significant figures, it's infinity. Okay, let's get rid of these things and let's look at count of objects. Count of objects, we're going to take, for instance, let's say we are told that we have 10 apples. Okay, so on 10 apples, we can say this one has infinity significant figures. Because apples are objects that can't be divided. Like once you divide it, it's no longer an apple. For example, if you divide an apple in half, you can't call it an apple. You can say it's a half apple. You see that? Yeah. So if an object cannot be divided, then it falls under what? Count of what? Objects. Count of objects. Okay, let's take a more hard question. Yeah, let's answer a question that looks a little bit harder compared to this one. Let's say we are told that we have 3 moles of water molecules, H2O molecules, and we are told to state the number of significant figures. Okay, let's say we are told to find the number of molecules present. And let's say we are told to state the significant figures of our particular answer that you're going to get. How do you do it? Okay, we know that, okay, let me get rid of these things since we have discussed these ones. Okay, so if you are given a question of this kind, if you're given this question, what you can do, you need first to understand what's a mole. A mole is just an equivalent of 6.022 times 10 to the power 23 particles. So in this case, we can say molecules, since we are dealing with molecules. So in one mole, we have that number of molecules present. So since we are told to find the number of moles present in 3 moles, we can say 3 times this particular number. So 3 times the Avogadro's constant. The answer that we are going to get, it's the solution for the first part. Then we need to do what? To state the number of significant figures. Okay, let's punch that into our calculator. 3 times 6.0, or we are saying 022 exponent 23. We are getting a 1.8066 times 10 to the power 24 molecules. So in this one, we can say it has infinity number of significant figures. Reason why is because a molecule of water, which looks like this, can be considered as an object. And since we are counting the number of objects present in 3 moles, we can say this one as infinity. Reason why: water cannot be splitted. Once you split it, it's no longer water. It changes its state. Yeah. So when you like split this part of water, you're going to remain with hydrogen ion. So you can't call it water when it's just H. So yeah, I guess now you understand what I mean by counting objects. So you might be given a question of this kind, then you might be told to state the number of significant figures. So provided you're dealing with counting number of particles or objects, just know that it has what? Infinity number of significant figures. Okay, let's create some space and discuss our last portion of Rule 6. So our last portion states conventional factors have what? Infinity significant figures. So when you say 1,000 meters is equal to 1 kilometer, this one has infinity significant figures. Now the question is, how do we use this one? Okay, let's say a question might be given this way. It might be told to convert 3.920 centimeters into, you might be told to convert them into kilometers. And you are told to consider number of significant figures. So how do you do it? So what you can do, let's get rid of all these things. We need to use the chain link method. So we're going to get our number of interest, which is this one, and say multiplied by the conversion factor. So the conversion factor for centimeters to, okay, let's convert centimeters to meters. We know that per every 100 centimeters, we have 1 meter. In short, 100 centimeters is equal to 1 meter. Multiplied by, now let's convert meters into kilometers. We know that 1,000 meters is equal to 1 kilometer. So now we can say this one times that one divided by that. Okay, so you can say 320 divided by 100 times 1,000. And the units will be, this part to cancel on that part to cancel that part. So we're going to get kilometers as our solution. So let's do that into our calculator. So when you punch this into your calculator, you need to get the value 3.92 times 10 to the power negative 5. But I want to write it as a decimal number, so I will write it as 0.0000392. Yeah, let's write it that way. Let's write it this way. So you're going to get this one as your solution, kilometers, by the way. Then if you're told to state the number of significant figures, or to write your answers with correct number of significant figures, you need to go back to your what? To your number that we are given. So in this one, we know that we have 1, 2, 3, 4. We have 4 significant figures. Remember, trailing zeros are what? Significant if you have what? A point in the number. So this one has 4 significant figures. But remember, this part, it has infinity. It has infinity significant figures. Remember, it's a what? A conventional factor. And when dealing with multiplication, we take the number with the least number of significant figures. More about that in future. I will explain it as we go on in this video. But just know, we are going to get the number of significant figures of this particular number, which is 4. So the answer must have 4 significant figures. Remember, reading zeros are not what? Significant. So this one has 3 significant figures. So we need to write it with 4 significant figures. So it should be written as 0.00003920 kilometers. So this must be your answer. So that's how we apply our last rule, which states conventional factors have unlimited significant figures. Okay, I've done a lot of talking. Let's handle some questions that you might encounter during your test and exams. So these extra rules are actually 2. There's one that governs addition, the other one governs multiplication. So let's begin with the one that governs addition and subtraction. This one. So this one governs addition and subtraction, and it states the result should be rounded off to the least. It must be rounded off to the least number of decimal places in the what? Original number. Okay, let's say as those in the original number. Yeah, now the English is correct this way. Let's take, for instance, we have 9.02 plus 3.1. Okay, let's evaluate this one. So if you have a question of this kind, we know you just need to punch it into your calculator. Plus 81. You are going to get a value of 40.02. Now, to consider your number of significant figures in this solution, you need to state the number of significant figures of each factor in your original number or your original expression. So in this one, we know that we have how many number of significant figures? We have 2. And in this one, we have 3. Now, don't forget, our main focus under addition is decimal places, not significant figures. Yeah. So we are interested in decimal places. So forget about significant figures. So number of decimal places in this one, it's 2 decimal places. Wow, this one, it has 0 decimal places. So your solution must have, it must be rounded to the least number of decimal places as those in the original number. So this one has the least number of decimal places. So the solution must have the same number of decimal places as this factor. So we're going to say this one will have 40 this way. So we can just write it as 40. So if you are told to state the number of significant figures, we can say this one has 2 significant figures. Okay, we don't need to put a point because in this one it did that. Yeah, it did not have a point. So we can just say this one has 1 significant figure. 1 significant figure. Okay, let's do another example. Let's say we have 100.093 minus 7.22. Then we're told to consider number of significant figures in our solution. So in this one, we can just punch it, by the way. 100.093 minus 7.22. And your value will be 92.873. If we were to consider the number of significant figures, we can say this one has how many number of decimal places? 1, 2. So we can say 2 decimal places. While this particular factor has how many numbers? How many number of decimal places? 3. So it's 3 decimal places. So I'm going to get this one. So it must have the same decimal places as this one. So I'm going to round it off to 2 decimal places. 8, 7. Remember 3 is less than 5, so you don't need to add a 1 to 7. So this one will be your solution. And this one has how many number of significant figures? Just for revision sake, we can say this one has 4 significant figures. So that's how you handle a question of this kind. Okay, let's dive into the last rule that you need to know, which is the rule that governs addition and division. So this rule states that let's get rid of everything. Okay, so we have this rule which states the result. By the way, we are talking about now multiplication and division. So under this one, the result, your solution, should have the same number of significant figures as the factor with the lowest significant figure. Okay, let's take, for instance, we have this question times 22.932. So if you have a question of this kind that you are taught to evaluate, this one will give us a value of 22.932, will give us a value of 207.07596. And if we were to consider the number of significant figures, we need first to state the number of significant figures on this one, this factor, which is 3 significant figures. Remember, we are dealing with the division, so we focus on the number of significant figures in each factor. In this one, we have 1, 2, 3, 4, 5. So it's 5 significant figures. So your solution must have the number of significant figures as it must have the same number of significant figures as the factor with the lowest significant figures. So this one. So let's ensure that this one has the same number of significant figures as that one. So it will have 3. So it will be 207. You can put a point if you want. So this one, we know that it has 3 significant figures. So this one must be your answer. Okay, let's do another example. Let's say we have a division this time. Let's say we have this number 0.002 or 372 divided by 0.11. Yeah. Okay, so in this one we know that it's division. So the rule applies. So you can just now punch this your numbers into your calculator. And you're going to get a value of 0.0338, 18181, so on and so forth. Okay, so this one will be your solution. But if we were to consider the number of significant figures for our solution, we can say the top part has how many number of significant figures? It has 1, 2, 3. Remember, leading zeros are not significant. Whether there is a point or there is no point, leading zeros are not significant. So this one has 3 significant figures. While the bottom part has 2 significant figures. So we're going to get the significant figures of the bottom part. So our solution will be 0.012. So we're going to round it off to that place. So it will be 3, 4 there, since 8 is greater than 5. So it will be this value as your solution. This one has how many number of significant figures? It has 2 significant figures. So that's how you go about a question of this kind. Okay, we are done with the rules. Yeah, don't forget, in addition and subtraction, we focus on decimal places. In multiplication and division, we focus on significant figures. Okay, let's handle some tutorial questions and exam questions now. Okay, let's do it. So we have this particular question that popped in tutorial sheet. That popped in tutorial sheet 1, 2024. Yeah. So yeah, we are told to perform the following mathematical operations. Express each answer in the correct number of significant figures. Okay, so we have A. So on this one, guys, pay close attention. There's something that I didn't explain that I need to explain on this stage. Okay, so we are given A, it's 9.04 minus 8.23 plus 21.954 plus 81.0. And we need to divide that by 3.1416. Okay, so in this question, what we're going to do, we are going to consider BODMAS. Yeah, we are going to consider BODMAS. Though I prefer using what I like calling PEDMAS. Yeah. This one stands for parentheses, this one exponential, division, multiplication, addition, subtraction. Yeah, they are one and the same, because in this one we say brackets, these two. This one division, this one multiplication, that one we say addition, and the last one is subtraction. They're just one and the same. Yeah. So let's follow this one. So we are saying parentheses. So let's begin with the things in the parentheses. So in the parentheses, we have addition and subtraction. Okay, let's work them out. So let's punch these things into our calculator, or these things into our calculator. So we are saying 9.04 minus 8.23 plus 21.954 plus 81.0. And that will give us a value of 103.764 divided by 3.1416. Okay, now what you need to do is that you need to come at this stage and state the number of significant figures of each factor in this particular part of this question. So this factor has 3 significant figures. This one has 3 as well. This one has 1, 2, 3, 4, 5. It has 5. And this one has 1, 2. Remember, there's a decimal place, so the zero, the trailing zero is significant. So it's 3. So the solution will have the number of decimal places. Oh, by the way, it's addition and subtraction. So we don't consider significant figures, but we focus on the decimal places. Yeah. So this one has 2 decimal places. This one has 2 as well, decimal places. This one has 3 decimal places. And this one has 1 decimal place. So your answer must have 1 decimal place. But I won't round it off to this value. Reason why accuracy when dealing with questions of this kind is very, very important. But I'll just put in my mind that this number ends there. So I'll put like a small bar at the bottom to remind me that this number ends there. So if I was to state the number of significant figures of this number, I need just to state 1, 2, 3, 4. So it has 4 significant figures. Forget about these numbers this side. Yeah. But I won't do that because accuracy is very important. So you don't round it off before reaching the final answer. Okay. So now we need to perform division. We need to perform division. So division, we know that we focus on what? Significant figures. So this side we have 4, as earlier said. Well, this side we have 1, 2, 3, 4, 5. We have 5 significant figures. So now you're going to go into your calculator and say divided by 3.1416. And that will give you a value of 3. Okay, I need to get rid of these things. Okay, this will give you a value of 3.029029799. But your answer has to be rounded off to it has to be rounded off to 4 significant figures. Yeah, it has to have the same number of significant figures as the factor with the lowest significant figure in your particular question. So in this one we have 4. So we're going to round off our answer to 4 significant figures. So we're going to say 1, 2, 3, 4. So it will be 3.0. Remember 9 is greater than 5, so it will be 3 there. So this one will be your final solution. So that's how we go about a question of this kind. You don't do your rounding off before reaching your final stage. So we did our rounding off at the final stage, but you need to be considering the number of significant figures at every step. Okay, let's do question B. Maybe you might even understand what I'm explaining better once we do question B. Okay, we'll be needing this in our future calculations. So let's get rid of these things. Oh, one more thing. The reason why I prefer using this particular mnemonic is because it has exponential in it. So supposedly you have a question that has exponents. You might fail to know which ones comes first between the parentheses and the exponents. So this one is better than BODMAS, because in BODMAS we don't have anything to symbolize exponents. Yeah, so I can recommend you familiarizing yourself with this one. It's a very, very nice thing to know. Yeah. So let's do B. So B states 0.1654 plus 2.07 minus 2.114. We have addition throughout, so we need to focus on the number of decimal places. So this one has 4 decimal places, this one has 2 decimal places, and this one has 3 decimal places. So when you perform your mathematical operation, we are going to ensure that our answer has 2 decimal places. Okay, let's do it. 0.1654 plus 2.07 minus 2.114. This one will give us a value of 0.1214. Okay, how many significant figures, how many decimal places are we supposed to round it off to? We need to round it off to 2. So it will be 0.12, since 1 is less than 5. So it will be this way. And how many significant figures are in this number? We have 2 significant figures. Very, very simple. Okay, let's undo C now. Let's undo C. Remember, we are rushing. We need to answer some questions from exam papers. So this time we have C, and C states 8.24 open 4.987 minus 4.962. Remember, we begin with parentheses. So parentheses, let's work it out. So in parentheses, we have 4.987 minus 4.962. will give us a value of 0.025. Wow. So we're going to get that value. Now this value will have how many number of significant figures? Oh, to know the number of significant figures, we need to know the number of decimal places in this factor and that factor. So in this factor, we have 1, 2, 3. So it's 3 decimal places. In this one, we have 1, 2, 3. Okay, they are the same. So our answer must have 3 decimal places. So it will have how many number of significant figures? For significant figures, it will be 2 significant figures. For number of decimal places, it will be 3 decimal places. Okay, now we need to finish our operation by multiplying this particular value by 8.27. So when you multiply that one by 8.27, you are going to get a value of 0.20675. Okay, so this one now, our answer must have the same number of significant figures as the factor with the lowest number of significant figures. So this factor, since we are doing multiplication, we need to consider significant figures, right? So on this factor, we know that we have 3 significant figures. And on this other factor, we have 2 significant figures. So our solution must have 2 significant figures. So we're going to say 2 significant figures, it will be 0.21. So this one must be your answer. And the number of significant figures, it's 2 significant figures. So yeah, that's how you go about a question of this kind. Okay, let's answer question D. Let's handle question D. So question D states 485 divided by 9.231. What are we dealing with? Division. Division, we focus on significant figures. So this number has 3 significant figures. Wow, this factor has 4 significant figures. So our solution, our answer will have 3 significant figures. Okay, now that we've established that, we can now punch that into our calculator. It will be 485 divided by 9.231. And your answer will be 52.540353. This one has to be rounded off to 3 significant figures. So it's 52.5 as your solution. This one, remember, it has 3 significant figures. So that's how you answer questions of this kind. Okay, let's handle this question. Let's say we have a question of this kind. By the way, this question is from a tutorial sheet, but I've forgotten which is which. Yeah. Let's say we have this question, 0.470 over 0.623 plus 0.705 over 0.4326 minus 2.526 divided by 3.1. Okay, so on this one, remember we need to start with division. We need to start with division before jumping to addition and subtraction. So let's do the division. So on this one, under division, we know significant figures is what matters. So in this one, we have 3 significant figures. On the bottom, we have 3 significant figures. So our answer on this part must have 3 significant figures. Okay, let's punch it. So we're saying 0.470 divided by 0.623. That will give us a 0.754414125. But we know that the number of significant figures must be 3. So it will be 1, 2, 3. So must end there. So let's put a kaba at the bottom to remind us that we must end there. Okay, plus let's do this next fraction. So in this fraction, we know that we have 1, 2, 3, 4, 5. We have 5 significant figures. So we have 5 significant figures. On the bottom, we have 1, 2, 3, 4. Remember, leading zeros are not significant. So in this one, we have 4 significant figures. Okay, now let's punch that into our calculator, which is 80.705 divided by 0.4326. 186.5580213 will be our solution. But we need to ensure that the number of significant figures are the same as the factor of the lowest significant figures. So the factor of the lowest significant figures, it's this one, the bottom one. So it must be 3. It must be 4, by the way. So we're going to end there. Okay, let's do the last part. So we are saying minus. How many number of significant figures are in this number? We have 1, 2, 3, 4. So we have 4 significant figures. The bottom part, we have 2 significant figures. So our answer must have 2 significant figures. So let's punch that into our calculator. 2.526 divided by 3.1. And that will give us a value of 0.81483870 or 71. Okay, so this one need to have 2 significant figures. So we are going to end at that point. Now let's add everything. Let's punch everything into our calculator since we have addition, subtraction. So these ones are governed by one law, which is the law that focuses on decimal numbers. So let's punch everything into our calculator to find the value. So when you punch everything, remember there it's plus, there, and there it's minus. Take note of that. So we're going to say 0.7544144125 plus 186.88. Okay, it's 5580213 minus 0.81483871, and your answer will be 186.4975967 as your answer. But we need to state the answer in the right number of significant figures. So this one has how many number of decimal places? Okay, let's begin with our first factor. This one has, remember, we are ending at that point. So it has 1, 2, 3. It has 3 decimal places. Take note of that. This one we are ending there, so it has 1 decimal place. And this one we are ending there, so it has 2 decimal places. So our answer must have 1 decimal place. So we are saying our answer must have 1 decimal place at that point. So to round it off to that point, it will be 0.5. If you are told to state the number of significant figures, our answer is 1, 2, 3, 4. It has 4 significant figures. So that's how easy it is to evaluate this particular problem, whereas considering the number of significant figures. Okay, let's handle now a question, an exam, or a past paper question. Yeah, let's handle a past paper question this time. Okay, we have this question from 2018, CH110, test 1. And this question was under question 1. Yeah. So we are told to perform the following calculations. Round the answers to correct number of significant figures. Units of measurements have been omitted. Yeah, so we are not given the units of measurements. Yeah. Okay, let's begin with A. I think on this question I won't answer the following question. I won't answer this one. I'll skip this one. I will only answer this one and question 4. Yeah, these two I want you to try them out because they are very simple. Okay, so remember, given 4 marks. Yeah, so this question and that question might constitute 1.5 and that question 1.5. Wow, this one and this one, it's half. Okay, let's do it. So question 1, it's 1.568 times 5.8 divided by 4.186. So in this one, we know that we are dealing with division. We are dealing with division, this thing, and we are dealing with division and multiplication. So we focus on the number of significant figures of each factor. So this factor has 4 significant figures, that factor has 2 significant figures, and this factor has 4 significant figures. So our answer must have 2 significant figures. Okay, so we know that our answer must have 2 significant figures. Let's do it now. Let's punch it into our calculator. 2.568 divided by, it has to be first multiplied by 5.8, then divided by 4.186. Your answer will be 3.558146202. Now you need to round it off to 2 significant figures, so it will be 3.6 as your answer. So that's how easy it is to evaluate this one. Okay, let's do the last question and call it a day. So question 4 says 4.18 minus 58.16 multiplied by 3.38 minus 3.01. Wow, this question was quite hard. Okay, so in this question, remember paired mass. We begin with parentheses, so we are going to begin with things in this one. So we are going to evaluate that one. Remember, this is minus. We are dealing with minus operation, so we need to focus on the decimal places. So this one has 2 decimal places, and that one has 2 decimal places. So our answer will have 2 decimal places. So let's do it. So we are saying 3.38 minus 3.01. And this one will give us a value of 0.37. How many decimal places? 2. Okay, we are good to go. Multiplied by 58.16 minus 4.18. Okay, so now let's focus on these two, on division. So when you focus on division, okay, I won't be needing, okay, we need every part in this one. Okay, I'll write it here on top. So when you do your division, remember on division, we need to consider significant figures. So this one has 4 significant figures. This one has 2 significant figures. So our answer will have 2 significant figures. So let's do it. So we have this value. It has to be multiplied by 58.16. And you are going to get 21.5192. It has to be rounded off to how many significant figures? 2 significant figures. So it's 1, 2. So we are going to end at that point. But we can't do the rounding off at this stage. We need to do it at the end. But we can just take a small bar at the bottom to remind us that the number ends there. Okay, now we need to perform minus. Minus, we need to focus on the decimal places. This one has 2 decimal places, while this one has 0 decimal place. Remember, the number ends on 1. Yeah. So now, when you punch that into your calculator, we have this one. When you punch it into your calculator, you are going to get a value of negative, so we are saying 21.5192. By the way, this must be negative, minus 4 or plus 4.18. So your answer will be 17.3392. So your solution must be rounded off to 0 decimal places, so it must be 17. So your solution will be negative 17 as your solution, negative 17. How many number significant figures? 2 significant figures. Okay guys, we are done. If you enjoyed the video, then you can consider registering if you haven't registered, so that you may be able to watch more of my videos from the app. Having said that, let's go it a day, and I'll meet you in the